Hi, welcome to this session about mobile DevOps and how to deliver great apps continuously. I guess many in the room have been in projects where there's only one person that are able to do a release, or maybe no one know how to do a release because the person that used to do the releases has left the company. So in this session, we'll talk a little about what DevOps is and how to apply it on mobile projects. So first, we'll take a look, not that one, at this circle, or the DevOps loops that it used to be called. It's describing the DevOps process. Many people think that DevOps is just CI and CD, continuous integration and continuous delivery. If you have set up processes for continuous delivery and continuous integration, you're doing DevOps. But I would say that DevOps is not about that at all. Okay, you need those processes to work with DevOps, but DevOps itself is much more about how you work to have a tight team working together, where you have both developer, testers, people from the business side, business analyst, product owner in one team that can work together and deliver value to the user. So I will say that DevOps is much more about to deliver value to the user and deliver value continuously to the user. You will not release every 3 months or once a year. You will deliver your apps or your software all the time. You will maybe doing multiple releases every week just to fix a few things to do the app a little bit better for the user. I know companies that deploying a lot of times the same day. For example, Azure DevOps. I listened to a podcast with Donovan Brown. They releases updates of Azure DevOps at least 10-20 times a week and doing improvements all the time. It's not that easy when it comes to mobile because at least on iOS you need to go through the Apple's approval process. But it will take about a day. So it's no problem to deliver a few releases every week. But what a friend to me used to say about DevOps, a DevOps team should not be bigger than that you can share 2 pizzas in the team. So it's all about to have a great team working tight together. And I think this is more important than the DevOps loop. This slide describes better about what DevOps is. It's about to build something and measure how it's used, how the user like it. It could be analytics, it could be crash reports, it could be talk to user. And from what you learned about how the users like the app, how they use it, if the sales increase, for example, you learn of that and you will go back and build changes from that. So that's DevOps to me. So it's not CI/CD. Okay, tools and process are important, and that's what we will talk about today. So there are a lot of great tools out on the market. Here are a few of them. You maybe recognize those logos, but today we will focus on those ones. We have Microsoft AppCenter, Azure DevOps, and Application Insights, and a little bit about the GitHub. So we will first start to talk about AppCenter. AppCenter is a great way to start with mobile DevOps and the processes you need for that. So Azure, I don't think the name is Azure AppCenter, it's Microsoft AppCenter nowadays, but it has support for iOS, Android, Windows, and Mac OS apps, and even Unity on iOS, Android, and Windows. And it's not, you don't have to build apps in Xamarin, for example, or any other Microsoft products. You can use React Native, Cordova, you can use Objective-C Swift, of course, Kotlin, Java, React Native, and Cordova on Android as well. So, but what you can do in AppCenter is you can build your app, you can test your app, test your apps on devices, and you can use it for distribution. You can distribute to different group of testers, and you can also, if you want, use it like a distribution for your enterprise. But I think the main idea about this is to distribute to alpha beta tests. So you maybe have heard about Hockey app before. AppCenter is the next level of the Hockey app and Xamarin Insights. And you also have diagnostics and analytics in AppCenter. I will give you a demo about that. So we leave the presentation and go into the AppCenter portal. I have built a small demo app, so we don't have so much analytics data to take a look at later. But first, we will go and take a look at the builds. This source code is hosted in Azure DevOps, but you can also host the code in Bitbucket or on GitHub. So when you go into the build tab, you will see all the branches that you have in your repository. And it's pretty easy to set up a new build. You just press this configure icon. Wait a few minutes. Not a minute, but a few seconds. And here you have a few settings here, so you can change to release, what mono version you will use, if it should build on every push, or if you will build your app manually. And you can also set it to automatically increment the version code of the app. And you can sign the builds, and you can also, this is interesting, I like this feature, you can test on real devices without to write any code at all. But what will happen then is it will test that the app will start, not more than that. But it's great to see if you start and you can catch that early if you have a problem to start, because if you when you're developing the app, you're probably just testing the app in debug mode, not in release. So there maybe are things in the release build of the app that makes it crash in startup. And if you test it on every build, you will fast find those problems. So we can take a look at the latest build I did here. And in the top of the header of the build, we have a link to the result. So we can go here. You can see that one test passed. It's often just running on one device for each build, but it will use different device every time it builds the app. So here we can see the screenshots. We can see hardware use, at least memory use. I don't know why we see CPU use, but you will see later when we focus more on test that we will also see how much CPU it consumes. And we will see the duration of the startup. And we can go in details here. We can see more about the actual device. And we can go and read the device logs. There are some exceptions here. I don't know what it is, but crash in native code, error parsing key for Android. Strange, the app looks like it's starting, so. So we can continue here to distribute. Here we can create different groups. We can have one group for the development team that is interesting to get every build to their devices. When a build is pushed to a distribution group, the user will get an email about it. It's not updated automatically on the device, so they have to open the email or click the link. So a distribution group can either be private, the user have to sign into it, or you can make it public. So we can go here, manage. Maybe not on that group. We will create a new one. Groups. allow public access. Then you will get a link you can just email to your users. If it is on iOS, you need to have all UDIDs in your provisioning profile. But AppCenter will help you to collect them. The first time a user get the email, or when you're adding them, they will get an invitation mail, and then AppCenter will ask them if they want to register their device to it. So you will have the UDIDs in a list, and you can export them and add them to the provisioning profile. You can also select if you want to AppCenter to do that for you. So if you're building with AppCenter, you can just add your Apple account and they will provisioning it for you. So the next step you can do with AppCenter is you can do a UI test. You maybe have heard about Xamarin Test Cloud. It's the same thing. Xamarin Test Cloud have moved into AppCenter. So if you go here, we can see my test rounds. Before I do a test round, I can go and create a device set. And here we can see I created two. One for dev that will run on every time we build, and one that I will run before I release to the Google Play or App Store if it's an iOS app. So for my dev build, I have selected 7 devices, and we can see that I have many more, 25 for my Google Play build, but we can create a new one. Update Prague. Then you can see here there are a lot of different devices. It's not just different manufacturers. There are also different operating systems on each device. So we can filter here on OS version, on tier, on manufacturer, and also on memory. So we can use low-end devices. If you're most interested to test on that one, is often those devices that had problems, because you as a developer probably are testing on a high-end device, but your user may be using cheaper devices that they bought on the supermarket on Black Friday, for example. So we can go back to the test rounds. We can select the latest one that doesn't is a startup test. This one is the startup test that will run with the build. So we can go here and see my test. It's just a simple app. It's a start screen, and then there's a list of episode of podcast. So we can see here that every test failed. It have a peak memory on 124 megabytes. And if we press the test here, we can go in and see more details. We can see screenshots on all devices that we have selected. It looks a little bit weird on a tablet. I don't know if it's just a test or if we maybe have a problem with landscape mode on those devices. And we can see the logs here, both the test logs and the device log. So we can try to find problems. We can also go to the other app, that is the iOS app, and see the test runs for that. You can, for example, take one here that has failed. There was no report. It was probably failed of some of my settings when I deployed the test. So here is the test for iOS. We can see here I have a icon as well, so probably I have some problems with my Android app. It's hard to detect that with just code, but if you go through all the screenshots, you will soon find those problems. And of course, if you have problems with the flow, you can navigate to the next view. It will show you an error in this portal here. So we can select the device, and we can see logs for test and device here as well. So this test I have created with code, and I have pushed it to the repository, and we run the code from that. So let's take a look at the code. Here I'm using Xamarin UI test, but you can use other frameworks as well. I think I have a slide about that here as well, somewhere here. You can use Appium, Espresso, Calabash. For example, if you're more used to use them, and you can also use AppCenter Test on other apps that doesn't just build with Xamarin. So you just need an APK and or an IPA file to run the tests. So, but for iOS, you need to link the IPA with the Calabash framework. You have to do that with Xamarin as well. So I will show you how to do that in a Xamarin app. But first, I think we can take a little look about how to write tests. So I can show you how to do the other part later. First, we have an app initializer that will be run when the test starts. It will check what platform you're running it for, and it will start the app. For iOS, I also added some debug code, because when I'm developing the tests, I want to start from the IPA file and point out where it's located. When running in the cloud, they know what the IPA is, so you don't have to point it out in the code. But starting the app on the device, and it will be ready for test. So here's the test code. We will add an attribute for each platform that the test will be able to run for. So this test is both for Android and iOS. If we add a setup attribute to a method, it will be run before each test. It's really simple to write those tests. It's basically this syntax. You have app.screenshots, take screenshots, app.tap. You can either use IDs for controls. At least if you use Xamarin Forms, it's very easy to set those IDs in code, and then you will use just x.marked and the ID you have for the control. If you're running on other devices, you can use REPL to see the complete tree of components, so you can find the ID that way. You can either use, for example, here I use task.delay to wait for the result, but you can also use wait for element and wait for a specific text to appear on the screen. But sometimes it works better to use just task.delay and wait 3 seconds. And then I will take one more screenshot. So on Android, you don't have to do anything with the APK. But on iOS, as I said, you have to link it to Calabash. So the only thing you need to do is just to call this method, xamarin.calabash.start, and you will get that when you install the new package called Xamarin Test Agent, I think. You can take a look here. Xamarin.testcloud.agent is the name of the NuGet package. But if you link it to Calabash, you will be not allowed to upload it to App Store. So then you have to create a separate build for your UI testing and one for your App Store release. So that's why I have added conditional compilers here. So if it's built with a configuration where I have this compile flag, it will link it to Calabash. So often I will have it on my debug build and my, for example, alpha test build that I publish with AppCenter, because AppCenter has no problem to publish IPAs that is linked to Calabash. It's only when you upload it to Apple. Okay, let's continue. If you want to do some more advanced stuff in your build process, in your release process, I recommend you to use Azure DevOps instead, because you can do a lot of more customizations in the Azure DevOps. AppCenter is a really good way to get started fast, but for bigger projects, I recommend you to use Azure DevOps instead. I will show you a little bit how you can set up your builds and releases and approvals of releases and things like that. But I will talk a little bit about what Azure DevOps is first. Azure DevOps is they changed the name to Azure DevOps for not so long ago. Before it was called Visual Studio Team Services, or VSTS. But Azure DevOps will handle work items, work item tracking. You will have Kanban board, Scrum boards, and everything like that. You have pipelines that includes build pipelines and release pipelines. You can have your code in Azure DevOps. You don't have to have your code in Azure DevOps. You can use other parts of Azure DevOps if you have your code on GitHub, for example, while Azure DevOps can connect to all Git repositories. So you can decide wherever you want to have your code. You can still use the part of Azure DevOps that you want. And in Azure DevOps, you also have support for test plans, and you have what they call artifacts. You can, for example, have your private NuGet fields inside of Azure DevOps. And Azure DevOps are free up to, I think it's 5 users. It was at least that before. And you have a lot of free build times as well. For open source projects, you have unlimited free build times in Azure DevOps, and you can easily connect it to GitHub, for example, and you can also install it to GitHub via the GitHub Marketplace. You can, I think it's called Azure DevOps Artifacts or something like that. So let's do a demo of Azure DevOps. It's the same app that we showed in the example of AppCenter. I will not focus so much on the work item parts, but I will just show you that you will have them here. You have boards, we can create new work items, we can create bugs and things like that. So let's create a bug. App is not working. A typical description of a bug when it comes from a user is not working. No more details about that. So we need to find that out. So let's go to the pipelines. And here we have a build pipeline that I've created. Azure DevOps has support for build agents. This runs on Windows, of course, but also on Mac OS and Linux. And it's Azure DevOps that are in the bottom of AppCenter as well. So it's the same build agents that are used for AppCenter that are used on Azure DevOps. So let's edit this pipeline to see how it's built. So in this pipeline, I will have different phases, because on one phase you can only select one agent. So one phase will be build the iOS app, one will be to build the Android app. And the Android app I will build on a Windows machine, and the iOS app I will build on a Mac machine. So the first thing the iOS build in this case will do is to set that we'll use NuGet 4.5, because otherwise you can get some problems with the new CS Pro format. And then we'll restore all the NuGet packages in the solution. And we'll also install the Apple certificates and the Apple provisioning profiles. And the recommendation for provisioning profiles and the certificates, and also for the Android key stores, is to place them in the library. And here you have secure files. So you can upload them here and store them in a secure way. And you cannot, as a user, you cannot read them here or download them. You can only upload them. So if you have permissions, of course. So no one can use them if they don't have permissions. So we will install that, and we will also bump the iOS version. This is a task created by James Montemagno, open source, that I have installed from the Azure DevOps marketplace. And it will go into the info.plist file and change the version for bundle, CF bundle version and CF bundle short version string. So, and in this case, I will use the build ID as the version code, and the build ID is just a number that increases for every build. You can also use the build format here for define a format that you want to use, for example. So let's go back to the tasks. There are also a preview of Azure DevOps that you can enable preview functions where you can define your whole build steps in YAML, and you can check it into source code and have it version handled. You can use a pull request for it and so on. You can also, if you want, here see the YAML for each task, but you cannot build the whole flow with YAML if you don't enable the preview features. But we will build the alpha version of the app first, that we will distribute to AppCenter or for testing. We'll copy the files of it to what they call artifact station directory, just to tell that we are just interested in the IPA files, and we will publish it to the artifacts storage so we can use it together in the so we can use it in the release pipeline. The next step, we will build the release app. So we basically will build the app twice. In some cases, I used to have two different build definitions. One for a dev branch, for example, that only builds the alpha version, but the master build for the master branch will build both alpha and the release one. Mostly because we want to test the alpha one with the AppCenter Test. And we'll copy the files here again and publish them. The Android build looks very similar. You don't have to install any certificates before the build, but we will sign it with the key store here later. Of course, you need to upload key store and certificates even if you use AppCenter, and they have a secure way to do that as well. So we will copy the files and publish them to the artifacts. And the last phase is to build the UI test project. You can build them in the same phase as the other one if you want, but I think it's been more clear to separate them. So it's only a simple Visual Studio build task that will create a DLL of the tests, and we will upload them. And we will also upload this testcloud.exe file, because it's used when you will publish the tests to AppCenter. So let's take a look at the release pipelines. I created two pipelines, one for the dev release and one for the master release. So let's edit that one so we can see how it looks. The dev is really simple. Every time a user push code to repository, it will build, and when the new artifacts are available, the release will pick it up and release it to AppCenter, and also run tests in AppCenter for that one. So we can see here that I have enabled continuous deployment trigger here. We can add other triggers as well if you want, but in this case I only have enabled the continuous deployment. In AppCenter task, we can AppCenter stage, we will have 2 tasks, one to deploy the iOS app to AppCenter, and one to deploy the Android app to AppCenter. Just the configuration, what app it is in AppCenter, where the IPA file is found. You can add release notes here if you want. If you want, you have to, but you don't have to write detail if you don't want to. And we have one other stage that is just to test the apps. And here I can select what device sets that should be used. So here I used Android dev of my account with some strange characters after it. It's auto-generated username. Yes. And we can select what language the app will run on. So there are a few defined here, but we can also select other and enter easy code, so we'll be able to run on all language that device supports. There's no problem to run it on a device for Czech or in Swedish or whatever you want. And the iOS is the same. You just have other values. So one of the strengths with to use Azure DevOps instead of Azure DevOps is that you have really good processes for doing pull requests and how to build a pull request and validate them. So let's go to the repository part of Azure DevOps. And you can see here that I have updated the make a change branch. So I will create a pull request for that. I can set reviewers here, and I can select a work item for that. So you can see, okay, this work item was for, this pull request was for fixing this work item or this bug. So let's create it. I set myself as a reviewer while I have permissions for it. And here the user are able to give comments on code, and they can approve the update, or they can reject it, or they can approve it with suggestions. So let's approve this update. And then you can see here that the build is still in progress, so we are not able to complete the pull request before the build is success. But we can set auto-complete, so it will be completed when the build has finished, if it's successful. So we can go to branches here, and we can see how to set up those pull request policies. So we can go to the master branch here, for example, and go to branch policies. So here we can set up the required number of reviewers, if users are allowed to approve their own changes, and so on. If we will reset the reviews when a new change is coming to the pull request, if it's required for the user to work item, if all comments need to be resolved, and so on. And here we can add what build definition that will be used to evaluate the pull request. Okay, let's go back to AppCenter and take a look of the analytics part and the crash part of it. I think we can start to take a look at crashes and errors, I will say. If we install the SDK on the app and just add AppCenter key to it, it will automatically track crashes for you. And here in the list you can see the crash. You can see some summary of how often the crash occurred, and but it's more interesting to go into this crash. You can see the stack trace. You can see most affected devices, just simulator in this case, but if you run it on a real app, you can see if it's an iPhone 10, it's an iPhone 8 or Android device. Android and iOS devices are separated in AppCenter because you have to create one app for each platform you are using. And you can also see most affected operating systems. Then you can go here to reports. You can see more details about the specific crash. Okay, here is signal B. Too many taps on the logo is the exception. It's because I added a button in the app to just crash the app, so I will have some data here. But if it's a real exception, you will see the message there. You can see when it happened, what country it is on the device, what language, affected operating system, the network carrier. And you can also see, if you're tracking events in your app, you can see all the events that have happened before a crash and how long in a session it was before each event and for the crash. So this crash happened 1 minute after the session start. You can see it here, and you can easily track what the user done before the crash. I used at least track every page view and also some other events if you press the button or everything that is related to the user interaction I used to track. So it's easier to see what the user did before a crash, for example, or before error. You can also see errors. Errors is a handle exception in an app that you need to track yourself. So here you can see we have one error, and this looks basically the same as the crash report. You can go and see reports here to see a specific error and what happened. The next thing you have here is analytics. You can see some summaries of how the user used the app. Many of this data is collected automatically when you adding the AppCenter SDK to the app. For example, active users, daily sessions per user, session durations, top devices, what language, countries, and so on, and what versions of the app that the user are using. And you also can see events here. So I don't think I have any events. I have page view created. So you can see here, for example, that main view is most popular and the episode view is less popular. And you can also see log flow live, what happened in the app. I don't know why you want to take a look at that, but it's possible. If you want to have more advanced analytics, and if you want to have analytics for the iOS and the Android version together, you can create a bridge to Application Insight in Azure. So let's take a look at that. Just have to go to the Azure portal. Chrome doesn't like full screen. So let's find my DevOps demo application insights. And here we can see no data is available. I had data when I looked at it before, but we can go here to users, for example, and we can change from last 24 hours. It's probably that why we can see any users in the overview. So here we can get data about the users for both platforms. Let's see if you can change period here as well. Doesn't look like that. But you can deep dive into the analytics here if you want to user session, events, user flows. And you can also, if you want, open the analytics tools, and you can write queries against the data, so you can create your own customized reports if you want. Okay, we'll summarize it a little bit about the flows I used to set up for my CI and CD process. I'm only working with pull requests in my projects because I think it's make the quality of the code and the app higher. So when a user makes a pull request, it will build a pull request and someone will code review it. If it's okay, it will be merged into the dev branch and it will be built by the dev build. If we're using unit tests, I run them in the build. When the build is successful, I will upload the app package to AppCenter so that the team can test it, and if we have stakeholders that are interested to test every build, they also can do that in an easy way. If we, for example, using test flight for the daily testing, it will take a lot of time before we can the users can test it, because if it's a new version and we want to have testers that do not have a Apple development account, Apple need to approve the first build of every new version. So that's basically why I'm using AppCenter. It's much faster to get releases to users. And on every build, I also used to run a few tests to verify that all flows are still working after the changes that are made to the app. And if you go to the release step, I will also show you a little bit more about this in the Azure DevOps portal. When emerging from dev, we have a master build that also, of course, running unit tests. And then we have more of a flow how we're doing things. First step, when a build has succeeded in the master build, we will test it with the UI tests in AppCenter. The next step is that someone needs to approve these tests, and the Azure DevOps have support for approving stages, as they call it, in the release pipeline. And when it's approved, it will be released a beta version of the app. And for the beta testing, I'm using Google Play and TestFlight, because in the beta test we will probably have more user, maybe external user that's not related to the company at all, and we have not any chance to collect their UDITs and information about their device. So it's easier to just use the tools from Google and from Apple to do that. And and the next step is someone has to approve that beta release, and if it's approved, it will be pushed to App Store for review by Apple, or direct to the users if you're using Google Play. So, as a last thing, let's go into Azure DevOps and take a look at how you can set up approvals. Go to pipelines, release. I will take a look at this master pipeline and we'll press edit. So here we can see all the stages I talked about from a moment ago. We have UI test stage, we have beta test, and we have the App Store phase. So what we can do here is we can go here and add post-deployment approvals, or we can go to the next stage and we can add pre-deployment approval. You can use both. It's basically doing the same. And we can select user here that needs to approve it before it can go on with deploying this stage. And we can also set the timeout if how long the user can approve it, and we can set some rules about the users. Also, if you have more than one, for example, we can set that approval order in any order, in sequence, or any one user. So anyone is enough that one user approves the the release. If any order, all have to do it, and in sequence it has to be in a specified secret. So I may be on the first step in the sequence, and but before before we can deploy the next step, my boss also needs to approve it. So it's very easy to set up here. And when approval is ready, Azure DevOps will send an email to the user that there are new changes to approve. So that make it more secure with new version, because only people with permissions can deploy to App Store. But you can do everything from the same portal. You don't have to go to App Store or to Google Play to do this kind of things. Of course, you need to set up some basic stuff in the first times, and you need to add your accounts and connections to Google Play and App Store. But when that's done, you can do everything from Azure DevOps, and I think it's really great. You remove the dependencies to a specific person, for example, that have all the key stores and certificates. Azure DevOps have all that for you, even if a person leave the company. Okay, any questions? We have a few minutes left. If there are questions, you can come here after, or I will go to the Ask the Expert zone. Or you can contact me via Twitter or LinkedIn, for example. Thank you for coming.